Hai, Assalamualaikum dan salam sejahtera. Welcome back to the Laboratory Safety course. My name is Dr. Muhammad Ibrahim Muhammad Tahir. I'm from the Department of Chemistry, Faculty of Science, University Putra, Malaysia. Okay, so today's topic is going to be on chemical management, and hopefully I'll be able to cover purchasing, inventory, storage, and chemical waste. So, as a recap before we move on, I want to talk about why we should be worried about laboratory safety. Okay, as you are students, postgraduate students, undergraduate students who will be working in a research lab, you'll be dealing with chemicals every day. And as we know, chemicals are hazardous. So this means that you have to take certain precautions when you're dealing with chemicals. So we worry about laboratory safety is because of the health of the workers, safety of the workers. We also want to be concerned about the community and also the environment. So laboratory safety is the right thing to do. We need to think about it because it's very important in our everyday life. So when we talk about safety, especially lab, okay, we are concerned about the laboratory safety. So there are certain things that goes into ensuring that our labs are safe. One of the things is the management, how the lab is managed. Where do we store our chemicals and instruments? Do we have a plan when we design our lab? Lab also deals with suppliers, we purchase chemicals, and of course when we do research we're going to be doing experiments, hence we're going to of course create waste as well. And how do we do that? And of course the most important thing when you talk about laboratory safety, it is all about the human factors. I mean, you guys, the students who will be working in the lab, how are you going to mitigate the risk, and how you're going to mitigate the hazard and reduce the risk while you're working in the lab. Okay, so a little bit of statistics. Okay, so for somebody has done this, they look at the curve of accidents in learning institutions, right? And they found out that about 37% of the accidents in learning institutions are occurred in labs. So this is why this course is very important in order to ensure that our lab is safe for everyone to work in. Okay, and more statistic. Okay, so if we look at the kind of accident that happens in the lab, this is from the lab safety at the University of California in 26 August 2013. They looked at the kind of accident that has happened. They inspected about 898 labs at University of California, and they found that 54 labs failed their safety inspection. And some of the issues that that the researchers did not follow when working in the labs, things like failure to wear fully closed shoes, they wear short skirts worn in the lab, failure to wear lab coats. This is quite an important thing. Okay, failure to wear eye protection, which is really important. And when dealing with certain chemicals, they didn't wear gloves. Some even eat and drink in the lab, which is a big no-no in our labs. And then of course other violations as well. So I think with these two statistics, we can incline to say that safety is very important. We do want to reduce the kind of accident that's happened in the labs. Okay, so a general definition when we talk about laboratory safety, it is the anticipation, recognition, evaluation and control of health hazard in the work environment to protect workers' health and well-being and to safeguard the community and the environment. Okay, so this is a definition when we talk about laboratory safety. So when we talk about laboratory safety, there are two words that are quite important. You'll see this a lot when you are dealing with chemicals. One is hazard and the other word is risk. Okay, so when we talk about hazard, it means that there's a potential to harm. So all the chemicals that you're going to be dealing with inside the lab, all of them are hazardous. It's of course how you use them correctly will actually reduce the risk, where risk is the probability that harm will result. So it really depends on you on how you use the risk. So we know that all chemicals are hazardous. Okay, so our rules and regulations are there to reduce the risk of working with all these chemicals. Topic is the Chemical Management Standard Operating Procedure. We're going to be looking at how we purchase our chemicals and what do we do when we receive them, okay? And then how we're going to classify and label them, and then where are we going to store those chemicals, and some form of an inventory system and to know at least where the chemicals are. And of course, occasionally we're going to do some inspection. So purchasing, receive and checking, classification and labeling, storage, key in inventory, and lastly, inspections. So these are the Chemical Management Standard Operating Procedure. Okay, all right. So since we are at the Faculty of Science, so I'm going to be focusing on how we do purchasing of chemicals in the science faculty. And if you're, of course, you guys are all new to the faculty. Maybe some of you have done masters here and now proceed to PhD, so you're probably a little bit familiar on how to do purchasing. Okay, so you identify the chemicals that you want to do in your research. And of course, the first thing you need to find is 3 quotations for those chemicals that you want to buy. So you have to find out 3 different quotations from 3 different companies for the same chemicals. Okay, and then the next step is to fill in the electronic request order, or ERO we called it. For the access to the ERO, only the main researcher, meaning your lecturer or your supervisor, will have access to this. So they will be the person who will have to fill in the ERO. Okay, once the ERO has been filled, okay, so your supervisor will print out 1 copy and you attach it with your 3 quotation and send it to our TDP office, which is Pejabat Timbalan Dekan Pembangunan. Okay, and hopefully they will process it and check that you still have money in your account. Once they have checked, then they will pass the form to the Bendahari, the bursar, and hopefully the bursar check again, everything is in order, then they will issue a purchase order, or we call it a PO. Okay, once the PO is out, the company will be notified, and of course then the company will actually be able to order the chemicals. Usually most company will not the PO is out. Okay, once they receive the once the company receive the chemicals, then they will deliver it to the faculty, and of course this will become with a delivery order, or a DO, which means that the supervisor will need to sign off, say that they received the chemicals in addition. Once the chemicals has been received, then payment will be made to the company. Okay, so the process can take from 2 weeks up to 3 months, depending on whether if there's no issues, or if there's issues sometimes can happen. I would, as a student, after you have sent your ERO, okay, and the most important thing is this part, is the PO to be coming out from the bursar office. Once you have already sent the ERO to the TDP office, I would probably after 2 weeks maybe check with them to see whether was there any issues with the process of the ERO. If there was, you probably want to rectify it, have the PO been out. So it's good to double check. You don't want to check it every day, okay? That probably annoys some people, but maybe after a week or 2 weeks, I will say after 2 weeks, do a follow-up just to ensure that everything has gone smoothly, and they can actually produce the purchase order. Okay, so that purchasing. And I know some students do get frustrated sometimes when the chemicals arrive late. So planning is very, very important into the faculty. Maybe in 6 months time, you know that you'll be doing a certain experiment at that time, so order your chemicals beforehand. Don't actually buy the chemical on the day that you want. You will never. This is because in Malaysia we don't have a lot of companies that actually produce chemicals. Most of our chemicals have to be imported, so it will take time. Okay, so that's the topic on purchasing at the Faculty of Science. Okay, so everything went smoothly. You have purchased your chemicals. Now the company is going to deliver the chemicals. All right, so the chemicals has arrived at the faculty. Now it's upon yourself to actually check. Okay, so one of the important things about when you receive a chemical, you must ensure that all the chemical comes with the safety data sheet, or SDS. Okay, so the safety data sheet, it used to be formerly known as the material safety data sheet, and I know if you look up on the internet, some still refer to as MSDS, but they have dropped the M. Okay, now it's just called safety data sheet. So each chemical will come with a safety data sheet. It's a must by the company to provide it. Okay, so if the company if you receive a chemical and the company did not provide the SDS, do not receive it. Okay, ask the company to come up with the SDS first. Okay, then you receive it. Okay, so you check first the label for information regarding, because the safety data sheet will have information with regards to the health hazard of that chemical, the kind of PPE that you need to wear in order to use those chemicals, and any other pertinent information about the chemical. That's why it's so important that the chemicals that you receive have the safety data sheet. And of course, you check the condition of the chemicals as well. The bottle, has it been opened? Is it, is there any cracks? Or, if you receive a bottle that the labels, you can see it clearly and it looks all brand new. Okay, so usually this is what I call a safety, this is a similar data sheet. Some of the safety data sheet now you can actually Google it on the internet. You can see it for certain compound, and for basically for each chemicals that you receive, you should have a folder in the lab to restore all the safety data sheet of chemicals that you have in the lab. I know that certain labs, they have a computerized system. Basically, you have a computer that log in or everything of your chemicals, and you can easily just search in on the database that you have in the lab. But I think some labs still maintain a folder where all the safety data sheet for all the different chemicals are stored there. Okay, are filed properly. Okay. So you receive your chemicals, you check that it has the safety data sheet. Alright, so one of the good things that you need to do is now you need to, of course, classify them. Alright, and then one of the best thing to do is to put the date you received this chemical. If an expiry date is mentioned on the item product information sheet, remark it on the bottle, maybe to put it as well on the bottle. Okay, so as a reminder, the expiry date set by the manufacturer indicate the shelf life of the unopened container. Okay, and do not necessarily imply that the chemicals is safe to use up to that date after it has been opened. So please take this as a reminder. The date of the receipt of the chemical is one thing, but also the date of the date that you actually open the chemicals also should be noted on the bottle. So use a permanent marker or anything like that to put it on the bottle, yeah, to say when you actually open the bottle for you to use. Okay. In special cases, like if a particular chemical becomes unsafe upon storage, for example like diethyl ether, then expiration date is vital to be included, okay, on the bottle. Right, so you have received the chemical, you have checked the safety data sheet, it's there for the chemical, and then you have actually labeled, you have put on the necessary dates of receipt, date of open on the bottle, so that you know everything is in check. The next thing is, of course, you need to do some classification, because in order for us to put in the inventories system, we need to be able to classify them. Okay, since most of our chemicals come from overseas, especially from the European Union, there is a body that looks after the classification of them, which is the European Custom Inventory of Chemical Substances, which is an information tool managed by the European Commission's Directorate General DG for Taxation and Customs, which allows users to clearly and easily identify chemicals, okay, classify them correctly and easily in the combined nomenclature. All right. So we use this the classification CNL inventory, which is a database that contains classification and labeling information on substance notified registered under the REACH regulation. Okay, it will also contain the list of legally binding harmonized classification. It is established and maintained by the European Chemical Agency. So if you want to be able to know some of the classification and the labeling system that people use for chemicals, you can actually look at this body here, the European Chemical Agency. Okay. So what about in Malaysia? Okay, so if in Malaysia, notification and registration of environmentally hazardous substance (EHS), this is administered by the Department of Environment. So you actually, when you receive certain chemicals, if it's environmentally hazardous, you have to notify the DOE. Okay, so importers of environmentally hazardous substances or chemical mixture or finished product containing EHS as consumer must register. This is quite important. So actually, this is the job maybe for your the company that actually buy those chemicals, import those chemicals from outside. Maybe their job is actually also to make sure they registers their chemical with the DOE. Okay, because it's very important sometimes to track the volume of those chemicals. Because these days also we have to think about chemical security, because we know that certain chemicals, if can be used wrongly and can be made into other stuff that could be very, very dangerous. Government usually will take stock of this, and that's why it's very important. They actually require by law, if you're buying chemicals that are environmentally hazardous or dangerous, you need to be registered at the Department of Environment, DOE. Okay, next we want to talk about the inventory. Okay, so when you have received chemicals in the lab, of course you want to be able to track them. Okay, we want to know where the chemicals are, how much we have. So an inventory system is crucial for any labs. All right, so the inventory system can either be an online database that that the lab has, or it could just be in a form of forms that you fill in and you fill it into a file. Okay, and this is definitely to ease the chemical tracking and management by any of the users, as the lab chemicals are usually going to be shared, isn't it, with other lab mates in your lab. Okay, so what are the crucial information that should be in an inventory system? Okay, of course, the date of receipt of those chemicals, expiry date of those chemicals as well, where you're going to store those chemicals. So location is very, very crucial. Of course, the SDS sheet. Sometimes these days, the safety data sheet is needed. Okay, any technical sheet as well, and of course the amount of usage. So one of the things that a lot of labs these days forget is that when you start using the chemicals, you need to also tell if you finish as well. So in the inventory system, maybe at the beginning you have 10 bottles of ethanol. So as you start using it, you have to update your inventory system, meaning that if you're finished, you say, okay, you left 9, 8, so that people know when they reach maybe 1 bottle left, then they can start ordering, okay, the same chemicals again. So these are an example of 2 forms that needs to be filled in at UPM for any chemicals. We have one which is called the Borang Inventory Bahan Kimia, the inventory form for chemicals, And then there's also a form here called Borang Daftar Bahan Kimia Berbahaya kepada Kesihatan. So any chemicals that are dangerous to our health must be listed as well. Okay, so these two forms should be in your lab in a file. Okay, at the moment we don't have if you have a computerized system, depending on which lab you are in, but most I think labs at our Faculty of Science still maintain using these two forms. Of course, there are other ways of keeping an inventory. This is an example of inventory form for enzyme for biological substances. Okay, basically they put this, I think, on the fridge, so you know what content is inside the fridge. Again, this is again for biological people. Okay, they work with bacteria again, so they have all the necessary information. Okay, that basically you know what's inside the cupboard, or I think this is the fridge lah, where they use. So this is another example of a very from other universities. Okay, so the chemical inventory system, and this one is this university basically have an online. Okay, so each person will have a username, a password, and then of course everything is put online, which is what would be the best. Okay, this is another example. And I think UPM is following suit, and they are still working on this. This still hasn't been approved, and it's still under construction. So hopefully in the near future we'll have a UPM inventory form online, a system that it will be much easier. So the idea is to have so that the whole of UPM is connected to the system, so that because we have so many labs in UPM, and of course there are going to be so many chemicals, maybe by having an inventory system online we can search that maybe if you need something urgent, for example you have ethanol, and of course ordering it will take probably 2 or 3 weeks maybe, but if you check the online system and you know, oh, the other lab has like bottles of ethanol, and maybe you can we can do what we call a lending system. You can borrow it from them, maybe 2 bottles, and you can start ordering yours and then replacement. That's the idea. So that's the beauty of having an inventory system that is online, so that we can share it throughout the university. So in case of cases like that where you need to find a chemical that you want to use it at that particular moment in time, maybe some other labs at the UPM will have it. Okay, so hopefully this will be a reality in the near future. Okay, so next we want to talk about, okay, so you have ordered your chemical, it has arrived, you have already labeled those chemicals, you have put it into the inventory system, but one of the things in the inventory system is that we need to know where you're going to store them. Okay, where is the location of that chemicals you bought, okay, where you're going to put it in the lab. Okay, so usually most labs will have what we call labels. Okay, maybe cupboard number 1, cupboard number 2, fridge number 1, fridge number 2. So we want to be very systematic in that way, so that when somebody else, a new person, comes into the lab and search the inventory system, they can easily go and find those chemicals. So like ethanol should be in cupboard number 1. It should be there. Okay. So the chemical storage and chemical waste have a standard operating procedure that follows the government rules as OSHA 1994. So the general storage procedures of any chemicals is that it should be stored securely. This is quite important. All right, it should be stored securely, because these days we are worried about chemical security. So it has to be protected from exposure to excessive heat, cold, or damage. Okay. Upon receipt of all chemicals should be entered into a laboratory chemical inventory. So this is what we've been talking about. Chemicals shall never be stored on the floor or on the shelf with open back. So this is for safety as well, which could allow the chemical to fall off to the back of the shelf. So when we talk about chemical storage, there are also going to be storage of incompatible chemicals. Some chemicals should not be stored together. Okay, so all incompatible chemicals must be separate based on their classes in order to minimize potential dangers of them if they are coming into contacts. Okay, so classes of incompatible chemicals include oxidizers, acid and bases, dangerous reactive chemicals, and solvents. So I'm sure you can find the list of incompatible chemicals and make sure that you don't store them together. Okay. When it comes to liquids, all right, especially solvents, I know we're going to be dealing with a lot of solvent in a chemical lab. Solvents should be stored in the supplier's original container or approved safety cans. And there is a limitation for each solvent. So maximum solvent container, if it's a glass, 5 liter, and if you use a safety can, it's about 20 liter. Okay. There are some exceptions. Okay, some flammable and toxic solvent must be stored in limitation capacity. Okay, such as diethyl ether that may not be stored in container exceeding 1 liter. Next, refluxing, and particularly refluxing over reactive material, should not be used for the ongoing preparation of solvents. What about storage for flammable and combustible liquids? Okay. So although these materials are generally used and stored in relatively small volume, nevertheless they present a fire risk. This is quite important here. We want to reduce any fire risk in our lab. So flammable and combustible liquid reagents shall be stored with regards to for their flammability, reactivity, and toxicological properties. So, flammable liquids are stored in refrigerators or freezers. The unit must be designed or have been appropriately modified to safely store such materials. So if you're going to store flammable materials in refrigerator, this must be an approved refrigerator or freezers that is already designed to store these kind of chemicals. Okay, so you have solvent, liquids, of course you're going to be dealing with gas as well. So most gas will come in cylinders and they are compressed gases. But one of the important thing with a compressed gas, because they are in cylinders, one of the issues with cylinders, they can easily topple and fall. So one of the things is you need to be able to secure them very well. So usually you secure them to your bench top or to a wall. Okay. And compressed gases should be stored also with due regards for their flammability. You have to be wary about their flammability, reactivity, and toxicological properties of those gases as well. Okay. Okay. So one of the important points here is that who are actually in the end responsible? Of course, it's you. You have to be responsible. But the most important person for each lab is actually the supervisors. Yeah, the lab supervisors are responsible for all storage of chemicals in laboratory under their supervision. Okay, so I think we'll stop there for a moment. Okay, so when we think about storage of chemicals, okay, and how your benchtop should look like, this is something that it should not happen in the lab. Okay, so you need to keep your lab clean and tidy. So this is a really good way of storing chemicals. Okay, it looks very tidy and in a systematic way, and as you can see, the cupboards are against the walls, so, and of course it will easy access as well for people to take the chemicals. One of the things that we should not do is actually put chemicals above our head and make it very difficult. I wouldn't this kind of putting liquids at the top is not the best. Okay, so it can easily topple over, although this image is trying to say that if you're going to take it, please use steps, but I wouldn't even do it at all. You know, you would not put something like a liquid in a large beaker at the top of the cupboard. Okay, this has the possibility, the risk of it falling over. So what are the general do's and don'ts of storage? Okay, So of course, one of the best do's is to store all chemicals by the hazard class. Okay, so example, one class is flammable, toxin, reactive, oxidizer. Then it could be stored according to alphabetical order. So you separate your chemicals according to their hazards. Okay, then inside the hazard, then you according them to alphabetical order. One of the don'ts is to store all chemicals based on alphabetical order. I know it's tempting, but that's not the way. We actually store chemicals based on their hazards. Okay, one of the do's again is some chemical fume cupboards have ventilated storage cabinets underneath, and this is a good place to put chemicals that require ventilation. The don'ts is to store chemicals near heat sources and direct sunlight. One of the do's is to use fume hood as storage for particularly odorous chemicals. So I know some chemicals are very odorous, and if you're working in the lab, you don't want to have these odorous chemicals evaporate, affecting everybody in the lab. So what you want to do is to use the fume cupboard to store them. Okay, but you have to be very cautious. The more containers, boxes, equipment, other items that are stored in the fume cupboard, the greater of having chemical vapor being drawn back into the room. So you don't want to use the fume cupboard as the main storage. All right. The next do's is if you have chemical that exhibit more than one hazard, you use the highest hazard to segregate it. Okay. The don'ts is store chemicals above eye level, as I said to you before, because if the container breaks, the content can fall onto your face. This is logic lah, of course, logical. You want to be able to buy chemicals in appropriate amount. You have to look at, before you do some purchasing, think about where you're going to store those chemicals. Do you have space for them? Do you need to buy 10 bottles of ethanol? Okay, or maybe you should just buy only 2 for the moment, because are you going to be using it? Maybe if you're doing a natural product, yes, maybe you have to buy a lot of solvent. But if you're in inorganic chemistry, you're doing synthesis, you don't need that 10 bottles all at once, isn't it? So you have to think about where you're going to place. Do you have storage for them? Okay, so you don't want to store excessive amount of chemicals, as this wastes space and creates unnecessary hazards. One of the do's, chemicals that require refrigeration should be sealed with tight fitting caps. Okay, you don't want to store chemicals on the floor. That's a no-no. Okay, so as I said to you before, when we store chemicals and when we classify them, we use it using their hazard class. Flammable chemicals, you have oxidizers, you have corrosive chemicals, reactive chemicals, toxin, and compressed gas cylinder. So that's why when you receive your chemicals, you must know where your chemical lies in the hazard class. So once you have already segregated them based on the hazard, then you can actually store them based on the hazard, and then you can follow the alphabetical order for each particular hazard. Okay. All right, so you have ordered the chemicals, you have received the chemical, you have put the chemical into an inventory system, you have the next step was you already classified their hazards, okay, and then arrange and store them accordingly based on hazard class. Okay, now you are doing your experiments. Okay, so what do you need to do once a while throughout the year? Possibly you have to inspect. Okay, maybe 3 months or 2 months, you probably should go around and check your chemicals. So the thing is to routinely, this is very important because we want to check for any signs of deterioration, okay, and of course the integrity of the labels. Okay, this has happened before, where sometimes when you use your chemicals, sometimes the labels get damaged. Okay, it depends on how you actually because there might be, especially solvent, the solvent might spill onto the glass and actually affect the labeling. Okay, so this should be inspection should be done regularly in order to check for this thing, sign of deterioration and integrity of the labels. because unknown chemicals cannot be shipped as chemical waste until a thorough analysis has been performed to identify them. So this is where the issue comes when you want to dispose of chemicals. So maybe you have a chemical that needs disposing, but it comes in a bottle that has no label. All right. So when you want to dispose the chemical, it's going to make it very difficult, because no company will take it unless you have done some analysis to determine what chemicals, because it's very dangerous just to remove those chemicals or to dispose those chemicals without knowing what it is, because you do not know. Because when chemicals react, something could happen, you know, it could be an explosion, or a fire might break out because two chemicals react. So you that take care of chemical waste will need to know. So it becomes very expensive to dispose of chemicals if they come in a bottle that has no label. It's very expensive. Okay, so you need to do proper labeling to prevent chemicals from becoming unknowns. This is very important. So you need to probably contact the safety officers for the disposal of any old, outdated and unused chemicals. So if you find that when you do your inspection and you find that some chemicals are no longer in but still has the label and everything, so this is where you contact your safety officer, okay, to think about disposing those chemicals. Okay, so here it says monthly inspections on the chemical inventory should be done monthly. Depends on your lab. Maybe some labs do it every 2 months, some do it every 3 months. With the lock is rather good. The next picture here shows where we can actually store flammable stuff. This kind of cabinet is good to store chemicals that are flammable. These are different type of fridges to store also your chemicals or your biological substance. But one of the important thing is to make sure that you put a note on the front of your fridges, so people know what is actually inside these fridges. Okay. All right. Okay. So here we can see the inside of the fridge. So you also have to make sure how the inside of the fridge looks like. This is a very beautiful arrangement of chemicals. They store it very well. As you can see, each seems to be all the chemicals have been put in a nice systematic way, and one of the important thing is also location, where you, especially like this one where you have the waste chemicals, is put at a corner away from everything else, but you should where the waste corner is in the lab. Okay, so the do's and don'ts of chemical storage. Okay, so we need to examine current availability of chemical by up-to-date chemical records. Okay, as I said to you before, never put chemicals on the floor. This is a no-no, floor clutter. One other thing is never transfer your chemicals into bottles that is meant for food. Okay, and this could be dangerous because you never know, somebody might interpret that as a chemical. Maybe especially when you have white compounds, they could be thinking about it could be sugar, custard sugar or something like that. So you never transfer chemicals into containers that was meant for food. And you shouldn't be eating anyway in the lab. You shouldn't have any food in the lab. So these are some examples where people have actually used food containers to store chemicals. And this is what I mean when you have chemicals. When you do your inspection, you see the bottles are already rusty. So this is where you need to actually talk to your safety officer in order to dispose this kind of. You don't want this kind of chemicals in the lab. So that's why inspection is very important. Okay, so the next one is we want to talk about waste. Of course, when you do chemical reactions, you're going to produce waste. So what do we do with this waste? Okay, and this is the most, I think sometimes this is one of the most important things that any researcher should think about, okay, when they start doing research. Okay, what am I going to do with the waste that I'm going to generate? Okay, so you have done you're doing your synthetic work and you generated waste. Okay, so what do you do with this waste? So in our country, Malaysia, the Department of Environment, DOE, is empowered under the Environmental Quality Act 1974 to control and prevent pollution and to protect and enhance the quality of the environment. They are the people that will look after these three different regulations, which are the Environmental Quality Schedule Waste Regulation 1989, the Environmental Quality Prescribed Premises Schedule Waste Treatment and Disposal Facility Regulations, and the Environmental Quality Prescribed Premises Schedule Waste Treatment and Disposal Facility Order 1989 as well. So all of the important aspect and procedures of this article are governed by the Environmental Quality Act 1974 Act 127. Okay, under this act there are as many as 16 regulations covering issues regarding environment and quality control. So out of these 16 regulations, one particular regulation had been amended 3 times, making it a total of 19. So these are the 16 regulations under the Environmental Quality Act 1974, and as you can see, point number 2, point number 3 and point number 12 all are dealing with waste. So under the Law of Environmental Quality Schedule Waste 1989, which was updated in 2007, the regulation would specify that before you dispose any waste, it has to be rendered innocuous. Okay, we want to be able to reduce the waste generated. Okay, generators meaning institution, like in our case, the university, who generate the waste must notify the Department of Environment. Okay, any waste generated must be able to be stored, recovered, and treated on site. Things like land farming, incineration, disposable off-site recover, storage, and treatment must be licensed under DOE. Waste containers, okay, that you put in your waste must be clearly labeled, all right, clearly labeled, proper and adequate. And all generators, in this case our university, must obey the requirement for consignment note system when actually transporting. So these are the Law of Environmental Quality Schedule Waste 1987 updated in 2007. Okay, there are about 170 categories under the schedule waste, which are grouped into 2 parts. One is part 1, the schedule waste from non-specific sources, and part 2, where it's schedule waste from specific sources. All these regulations, you can actually, if you want to know a bit more further, you can actually go to the Department of Environment, and they have all these acts underneath. Okay, so I will skip that, and I will straight away talk about a type of chemical waste from labs. Okay, so chemical waste from laboratories for treatment and disposal at the Integrated Schedule Waste Treatment and Disposal Facility at Quality Alam. So there is a company called Quality Alam Sdn Bhd that will take our chemical waste. Okay, and they are there's one disposable facilities of this Quality Alam at Bukit Nenas Port Dickson. Okay, so what they do is they take our chemicals, and the type of chemicals that are generated from our labs can be divided into type B, which is halogenated waste. You also have toxic waste, and of course type H and Z are the waste. So Quality Alam has described these 3 different types of waste that can be generated in labs. Okay, so beside this main type of waste, which are required to be sent to the Integrated Schedule Waste Treatment and Disposable Facilities, there could also be alkaline waste, acid waters, and water immiscible waste. Okay, there are also chemicals that are abandoned discarded or disposed into the atmosphere. You can also place on any soil or surface or of any land or inland waters. All such chemicals need to be disposed of in a proper manner so as to ensure that it does not affect our health and environment. Okay, so I think one of the important things people talk about these days is that because we are generating so much waste, sometimes the best way is to minimize the amount of chemical waste we produce. Okay, so the best approach when it comes to chemical waste management is not to produce waste, but unfortunately this can't happen. We are going to produce waste, the most important is to produce less waste, or to produce waste of reduced hazard. And so there's been ways to promote this in research. One is by proper waste management. The other is by changing practices so that they do not generate a lot of waste. And of course, by selection process that inherently produce less waste. That's why as a student, as a researcher, when you want to develop your procedures, okay, when you to develop your synthetic method, you should always think about the waste that you going to generate. If there is another way or another solution that can produce less waste, then therefore you should try at least to think about going down that particular route. So this is why planning is important, and identifying the steps in your reactions which can probably produce less waste or maybe produce less hazardous waste. So planning is very important when it comes to thinking about the kind of waste that you're going to generate. The other thing is by recycling and reusing generated waste, or also by reducing the volume of waste that must undergo disposal, and by selecting non-hazardous and less toxic material and processes. So basically we need to evaluate our waste management from time to time, or maybe to evaluate our procedures when we're doing stuff. Okay, you need to check, are we going to produce less waste, or are we going to produce less hazardous waste? So something to think about when you actually start your research. Okay, so now we want to talk about so you have generated the waste, so how do we dispose it? Okay, so any waste that disposed in our lab, it has to be endorsed by the internal chemical waste management of the faculty. Okay, so toxic or hazardous waste should not be disposed of down the sink, drain, or into the atmosphere. That's really important. Okay, if you have acidic or alkaline waste, it should be neutralized before it is disposed down the sink or the drain, or disposed into a pit. We want to be able to dispose of chemicals quite quickly to avoid accumulation or large stocks. Okay, in our faculty, basically the idea is that in our lab, we probably have 1 or 2 or 3 waste bottles for all our different waste. So when it gets full, those bottles now will be transferred to another location. We call it the chemical waste store. Here we have one in the faculty. And then once that gets filled up and full, then we'll be calling the quality alarm to come and pick it up. Right? So we don't want to store a lot of our chemical waste in our lab. So there will be like 1 or 3 bottles. So you have to monitor that. So if basically if it's getting too much, it's getting full, then you have to contact the safety officer, the chemical waste manager in our faculty, and then arrange time for it to be transferred from your lab to the chemicals waste store. Okay. Any chemicals immiscible with water must not be discarded into the sink or drains. Flammable solvent must certainly not be discarded as well. All waste solvents should be collected in the appropriate waste container and clearly labeled. This is very important. It must be labeled. If it's not labeled, we're going to have a problem with quality alarm later. Alright, they will not pick up our chemical waste if it's not properly labeled, because they will have to know what our waste chemicals are in order for them to dispose of them correctly. Okay, and make sure that the waste container should not be filled to the brim. Always leave some airspace. Okay, So when you have a solvent, where solvent mixtures are collected, the name of each solvent component should be specified. Avoid, if possible, mixing waste solvent. Chloroform waste should never be mixed with other solvent because it may react dangerously with impure acetone. And of course, another dangerous waste is mercury. This should be collected means by suction pump or placed in a bottle seal and sent for this. But this should never be mixed with anything. Usually when you have mercury waste, you tend to have a little small bottle where you collect them and put them inside those this container. Okay. Right. So in order for us to collect and store the chemical waste properly, a container must be chosen such that it will withstand any kind of chemical attacks by their contents. So the container must be leak proof and gas tight. It should be labeled clearly. Again, I don't know what I emphasize this a lot. Yeah, label clearly because we don't want issues later on when we want to dispose them. It must be located in a well-ventilated place, just in case if you have some odorous chemicals, if it becomes very odorous, you need to be put. You must make sure that the containers are put in a well-ventilated place, and so it must be kept tightly closed at all times to stop volatile materials escaping. So this is just a little show of diagrams that where you don't want to mix different chemical waste. Okay, you should not do this. This is the issues when it comes to when you want to dispose of chemicals and suddenly you don't see there's no label on the bottle. This is the big issue. That's why inspection is needed. So at this stage, if you have done your inspection and if you see that your label is becoming more and more ragged like this, you could probably replace this, okay? But once it's at this stage, when there's no label at all, you're going to have a problem. What is the chemical inside here? So the tendency usually people do is they tend to put it away, put it at the back of the cupboard, ignore it because they know they cannot dispose of it because there's no label. So they tend to forget about it. But then it will be a problem for the next person coming into the lab. So I think something has to be, you really need to be careful. That's why it comes to inspection is very important. You must at least do it, once in a year or, some people do it every month, some quarterly. So inspection must be done. So we don't want this kind of cases to happen. Okay. Right. So this is actually one issue. You never use your sink as a place to dispose of your waste. Okay, so this is the basic procedure of waste disposal from a lab, especially in the Faculty of Science. Okay, so there is a scheduled waste management. We do have a waste management committee in our faculty. Okay, so the first thing is you as a students, you must be able to identify the waste that you're producing, okay, according to the guidelines. We collect all the different waste usually in Winchester bottle, okay, according to their categories. And because one issue is if before you throw the waste, if the bottles are not fully filled, sometimes people consider that as byproducts. Okay, so when the bottles are filled up, the waste will be sent to the waste store, and for the collection of waste open, usually this store in our faculty will open at specific times, okay, specific time and day during the week. So this one you need to talk to the lab manager of your lab and find out what day is what day is the waste store open. Okay, it's not open every day. So usually there will be a specific time and day when it's open, so you have to know this. Next is then once the chemical stored in the waste store is full, then we usually contact Quality Alam to actually come and dispose of it. So generally this is how it looks like the flow chart for the scheduled waste collection. One other thing you must make sure, you have to ensure is that you don't mix incompatible waste. All right, because it could be potentially explosive, and those incompatible waste such as chlorine with alcohol, CHC, chloroform with tetrachloromethane here, with powder aluminum or magnesium, acetone and chloroform should not be mixed, ammonia, okay, with the halogens, ethanols with calcium hypochlorite, silver oxide with ammonia and ethanols, dimethyl sulfide with CrO3, nitric acid, okay, with acetic anhydride or acetic acid. So these are things that you have to be familiar, you have to be aware so that you don't mix incompatible waste, because there's a potential of explosion that can occur. Okay, so and also you need to think about the segregation of waste, because not all your waste are going to be liquid. Okay, so there's solid waste, there are aqueous, heavy metal solution waste, there are non-halogenated organic solvent waste, there are halogenated inorganic solvent waste, oils and mercury waste. So you must be able to categorize where your waste is, either in one of these categories. So in general, in summary, when it comes to waste management, all right, that is done at the department and faculty, we identify the classes of waste. Then we do the collection of waste, we label them, we store them, and of course there's also an inventory of chemical waste as well. So at least we can keep up on how much waste we are producing. And then when it comes time to dispose of it, we'll call quality alam. They will do the packaging, transportation, and the disposal of those waste. Remember, when quality alam came, this is not free. Yeah, of course, there will be a certain amount of money. So of course, the faculty of science, of course, we want to be able to reduce the number of time we call quality alam. Okay, so there is responsibility to think about reducing the kind of waste that you produce from your reactions. Synthesis. Think about it, okay? Think about your reaction fully. Are there ways of reducing your waste? Is that the best procedure that you can actually use? Maybe there's other routes. So this is something that you need to sit down and discuss with also your supervisor. Okay, so with that, I come to the end of my topic, which is chemical management, and I hope that you have will actually help you in your research at the Faculty of Science, University Putra Malaysia. So thank you very much.